In chapter 12, we want to talk about mechanical waves and sound. Now, sound is a specific example of a mechanical wave. When we think about waves in general, we have a bunch of different examples of that. So we've started out by saying sound is a wave. It's caused by regions of dense or rarefied air that propagate through space. We also have ocean waves, another type of wave that's mechanical. We have earthquakes, which locally don't look like it, but if you step back, earthquakes involve propagation of mechanical waves to the earth. And then finally, we have a type of wave, which is not a mechanical wave, but light, which will be treated a lot in this class. Light involves the propagation of waves using electromagnetic radiation. So when we say a mechanical wave, what's implied in here is that they use a medium. So in the case of air, for sound, air is going to be that medium, or sound waves can also travel in water, both for communication or they just travel when things happen. It's the mechanism for sonar. So we're going to say mechanical waves use medium or a substance to propagate. We're also going to say this: if the motion of particles in a medium is simple harmonic, as we saw in chapter 11, then what we notice is that that wave is going to be called a sinusoidal wave. And what's great about that is that when a wave is a sinusoidal wave, it can be simply described using a sine or a cosine function, and you're going to be experts at that. Called a sinusoidal wave. I notice as I'm writing all this down that it's not going to be as neat as what's in your book, but I'm going to follow along with what's happening in the book. I'm going to follow that thread of thought that goes through there. Now, when we talk about these waves, we're going to be concerned with two types of wave as well. So the first type of wave is going to be a transverse wave. And in a transverse wave, the wave propagates in this direction, and the particles are going to move perpendicular to the direction of travel of the wave. So an example of this would be if I had a rope, for instance. And as the wave, and pretend that this thing that I've drawn here is a rope, it's traveling to the right with some velocity v. But notice that at any given point in that rope, the particles are going to move up and then they're going to move down. So the motion of those particles are at 90 degrees to the velocity. Now the other type of wave is when the particles move in the direction. Well, they move forward and back in the direction of propagation, and those are longitudinal waves. And the best example for that is going to be sound. And particles move parallel. If you look at what happens to air molecules, and I'm just drawing a bunch of, trying to draw random particles. If a wave is traveling in this direction, what happens to an individual particle is it's going to move forward and then it's going to move back. So all these little particles are moving back and forth in the direction of travel. Actually, what's happening is you have, like I said, little regions of denser air, and these regions of higher density propagate in the direction of that wave with some velocity v. And when we consider these transverse waves, like I said, sound, for instance, is going to be a longitudinal wave. And then in the case of that rope, that's that transverse wave. Water is going to be mixed. So in the case of a water wave, you're going to have particles that move, well, the particles in the ocean, in the water, they're going to move both perpendicularly to and parallel to that direction of propagation. So if I consider, a bunch of waves like this that are moving in this direction, if I consider a little molecule, some of them will be going this direction and some will be going the opposite way, and they'll have little partial circular motion, and it gets very complex. But in all these cases, all these waves are going to move with some wave speed, and we're going to use a little stylized view for that. And so at this point, this tells us exactly what we're trying to study in this chapter, and you can read about it in that first section as well.